Tonight, there is nowhere you need to be, nothing to solve, nothing to remember. For the next little while, the universe can carry on without asking anything of you. Allow yourself to settle into a comfortable position. Feel the gentle weight of your body supported beneath you. Notice your breathing, slow and natural, arriving exactly as it is meant to. With every calm breath, the busy thoughts of the day can drift a little farther away. Now imagine that it is a perfectly clear night. The air is cool but comfortable. A light breeze brushes gently across your face. Somewhere in the distance, leaves softly rustle together, and above you stretches one of the oldest sights any human has ever known. The night sky. Thousands of tiny points of light shimmer against an endless ocean of darkness. Some glow softly with a warm golden color. Others sparkle with hints of blue or white. To your eyes, they appear peaceful, almost motionless, as though they have been quietly waiting there forever. People have looked up at these same stars for countless generations. Ancient travelers followed them across deserts and oceans. Farmers watched them mark the changing seasons. Sailors trusted them to guide ships safely across dark waters. Children wondered what they might be, while philosophers imagined worlds beyond imagination. Long before telescopes existed, the stars inspired stories. Entire civilizations connected bright lights into familiar shapes. Hunters, lions, birds, rivers, heroes, and mythical creatures slowly appeared across the sky. Every culture created its own maps among the stars, giving meaning to the beautiful patterns above. Yet the truth turned out to be even more extraordinary than the stories. Those tiny lights are not tiny at all. Many are enormous suns, scattered across the vastness of our galaxy. Some are larger than our own sun by dozens of times. Others are so immense that millions of Earths could fit comfortably inside them. And still, from here, they seem as delicate as grains of glitter resting on black velvet. There is something wonderfully calming about that thought. The universe does not hurry. Stars are patient. Some have been shining for billions of years, long before Earth had forests, before dinosaurs wandered the land, before the first humans ever looked upward with curious eyes. Tonight, instead of simply admiring these distant lights, we are going to visit one, not with rockets, not with impossible speeds, but with imagination, the quiet vehicle that has always carried humanity farther than its feet could travel. Imagine yourself becoming wonderfully light. The ground beneath you gently fades away. Gravity loosens its familiar grip. There is no sudden movement, no rush of wind, only the pleasant feeling of floating upward as effortlessly as a feather carried by calm air. The earth slowly slips below. Cities become clusters of tiny lights. Roads fade into thin lines. Mountains soften into gentle shapes. Clouds drift beneath you like peaceful white islands resting upon an endless blue sea. Higher still, the atmosphere gradually becomes thinner until the sky changes from bright blue to deep violet, and then into the rich, velvet black of space. Yet this darkness is not empty. It is filled with quiet light. The earth glows gently behind you, wrapped in a delicate blue ribbon of atmosphere so thin that it seems almost fragile. From this distance, every ocean, forest, mountain, and city becomes part of one beautiful world turning silently through space. There are no borders visible from here, no roads, no nations, only one small, beautiful home. Take a slow breath and allow yourself to drift even farther. Ahead, countless stars surround you in every direction. Without Earth's atmosphere to blur their light, they appear sharper than ever before. Each one shines steadily, no longer twinkling, revealing itself as a distant sun quietly burning across unimaginable distances. Some of the light reaching your eyes tonight began its journey before the Roman Empire existed. Some left their stars before the pyramids were built. Others have traveled for hundreds, thousands, even millions of years before arriving at this very moment. Light itself carries history. Every tiny beam is a messenger from another place, another time. Somewhere among these countless stars is one that will become our destination. Not because it is the biggest, not because it is the brightest, but because it offers us the perfect place to understand one of the universe's greatest wonders. What truly happens inside a star? From far away, stars appear simple. A glowing point against the darkness. Yet beneath that calm golden light lies a remarkable world unlike anything found on Earth. There are no solid mountains, no quiet oceans, no peaceful forests. Instead, there are flowing rivers of glowing plasma, gentle storms larger than entire planets, invisible magnetic fields stretching millions of miles into space, and deep within the center, tiny atoms quietly joining together in a process that has illuminated the universe for billions of years. Without stars, there would be no sunrise, no warmth, no oxygen, no carbon, no iron in your blood. Even the calcium inside your bones was once forged within ancient stars that lived long before our own sun was born. In a very real way, every person has carried a little stardust with them since the day they were born. Perhaps that is one reason the night sky feels strangely familiar. It is not entirely separate from us. It is part of our own story. As we continue our peaceful journey, we will travel slowly through the layers of a living star. We will discover how gravity quietly shapes its heart, how light patiently begins an impossibly long journey towards space, and how these silent giants spend billions of years creating the very ingredients that make life possible. There is no need to remember every detail. There will be no questions waiting at the end. Simply listen, imagine, and allow the gentle rhythm of the universe to carry your thoughts wherever they wish to wander. Far ahead, one golden star slowly grows brighter. Its warm light welcomes us without sound, without hurry, without expectation, and together, we begin the quiet journey inward. As our quiet journey continues, the star ahead shines a little brighter. There is still no sound, no wind, only the endless calm of space, where even silence seems to have its own gentle rhythm. For a moment, pause and look around. Every direction is filled with stars. Some appear close together, while others are separated by vast stretches of darkness. Their colors are subtle but beautiful. Here and there, a cool blue star glows like polished ice. Nearby, another shines with a soft golden warmth. A few seem almost orange, their light carrying the gentle color of an autumn sunset. from this peaceful place, it becomes easier to understand why people have always looked upward with wonder. Long before there were books, long before cities filled the landscape with bright lights, the night sky was one of humanity's greatest companions. Imagine standing on an open plain 10,000 years ago. There are no engines, no electric lamps, no glowing screens. When the sun disappears below the horizon, darkness arrives slowly, and then the stars appear in breathtaking numbers. Thousands upon thousands of tiny lights spread across the heavens, bright enough to cast faint shadows on the ground. For our ancestors, this was not an unusual sight. It was simply every night. The stars became familiar friends. People noticed that some always appeared in the same patterns. Others slowly moved across the sky. The moon changed its shape. Certain bright stars returned with each season, quietly marking the passage of another year. Without realizing it, early humans had begun studying astronomy, not with telescopes, but with careful observation. Farmers discovered that the appearance of particular stars often signaled the best time to plant crops or prepare for harvest. Hunters watched the heavens to predict the changing seasons. Sailors learned that the stars could guide them across vast oceans where no roads existed. Even in complete darkness, the sky became a map. One of the most famous examples is the North Star. Unlike most stars, it appears almost perfectly still, while the rest of the sky slowly circles around it through the night. Travelers in the Northern Hemisphere relied upon this dependable point of light for centuries, finding their direction even on the quietest nights. Imagine crossing an endless desert. The sand cool beneath your feet, the stars stretching above like scattered diamonds. There are no signposts, no landmarks, only the patient guidance of the heavens. It is remarkable to think that countless journeys reached their destination because of distant stars shining many trillions of miles away. As civilizations grew, so did their stories. In ancient Greece, people imagined heroes and mythical creatures among the stars. In Egypt, the heavens reflected the journeys of their gods. Across China, astronomers carefully recorded unusual stars, bright comets, and celestial events with astonishing accuracy. Indigenous cultures around the world created their own rich traditions, seeing rivers, birds, ancestors, and sacred animals woven into the night sky. Each culture looked upward. Each found meaning, and each was inspired by the same universe. Yet for thousands of years, one important mystery remained. What exactly were the stars? Some believed they were tiny holes in a great crystal dome, allowing heavenly light to shine through. Others imagined eternal fires carried by divine beings. Some thought the stars were attached to enormous invisible spheres surrounding Earth. These ideas were understandable. After all, stars seem so small. How could anyone imagine their true size? The answer began to emerge only a few centuries ago. As telescopes improved, astronomers discovered something astonishing. The stars were not tiny lights at all. They were enormous suns. Our own sun, which feels so unique, is simply one ordinary star among hundreds of billions in the Milky Way galaxy. Suddenly, humanity's place in the universe became both smaller and far more beautiful. Imagine replacing our sun with one of the largest known stars. Some would stretch far beyond the orbit of Mars. Others would reach almost to Jupiter. If our own Earth somehow remained nearby, it would not simply become warmer. It would disappear completely inside the star itself. Fortunately, our Sun is much gentler. It is a medium-sized yellow star, perfectly suited to provide the steady warmth that has allowed life to flourish for billions of years. Not too large, not too small, bright enough to nourish forests, oceans, and every living creature, yet stable enough to shine with remarkable consistency. Perhaps that quiet reliability is one of its greatest gifts. Even so, stars are incredibly diverse. Some glow blue because they are much hotter than our Sun. Their surfaces can reach temperatures of more than 30,000 degrees Celsius. Others shine with a softer red light, burning far more slowly and peacefully. These cool red dwarfs may continue shining for trillions of years, far longer than the universe has existed so far. Each color tells a story. Each brightness reveals something about the star's size, temperature, and age. Astronomers have learned to read these silent messages much like a musician reads notes on a page. Without touching a star, without traveling to it, they can understand its composition, its motion, and even the elements hidden deep inside. It is one of science's quiet triumphs. Learning about distant suns using nothing more than the light they gently send across space. Now, as we continue drifting closer to our own destination, the star before us no longer looks like a tiny point. Its round shape becomes clearer. Golden light spreads softly into the darkness. The blackness of space slowly gives way to a warm, welcoming glow. Ahead lies a living sphere of plasma, a place where gravity and light have maintained a delicate balance for billions of years. Soon, we will leave behind the familiar emptiness of space and approach the glowing surface itself. For the first time, we will see what a star truly looks like up close. And our peaceful journey inward, our journey continues. The quiet star before us grows larger with every peaceful moment. There is still no feeling of speed, no rushing wind, no roaring engines. Only the gentle sensation of drifting through an ocean of silence, where distances are measured not in miles, but in light itself. Behind us, Earth has become a beautiful blue pearl, suspended against an endless sea of black velvet. From here, it looks impossibly calm. The storms, the cities, the mountains, the oceans, all blend into one graceful sphere, slowly turning beneath sunlight. It is humbling to realize that every person who has ever lived, every conversation, every dream, every great discovery has taken place on that tiny world now resting quietly behind us. Ahead, our destination shines with growing brilliance. This is our sun, the nearest star. A faithful companion that has watched over Earth for about 4.5 billion years. Every morning, it quietly announces a new day. Every evening, it slips below the horizon without asking for applause. Its steady rhythm has shaped nearly every living thing our planet has ever known. Imagine approaching it without fear. In reality, no spacecraft carrying humans could survive such a journey. The temperatures become unimaginably high. Powerful radiation fills the surrounding space. Streams of charged particles race outward in every direction. But tonight, our journey belongs to imagination. Here, we may drift safely wherever curiosity leads. As we move closer, the sun no longer resembles the smooth yellow circle we see from Earth. Its surface begins to reveal remarkable detail. The bright golden disk slowly transforms into a living landscape of light. Soft patterns ripple across its face. Tiny bright cells cover every part of the visible surface, almost like the bubbles gently rising inside a pot of simmering water. Except these bubbles are enormous. Each one can be wider than an entire country. Some are larger than Earth itself. Astronomers call these patterns granules. They are created as incredibly hot plasma rises from deeper inside the sun, cools slightly near the surface, and slowly sinks once again. The process never truly stops. It is the quiet breathing of a living star. Every few minutes, one granule fades away. Another appears beside it. Billions of these glowing cells are constantly forming, changing, and disappearing across the surface. If you could somehow watch the sun safely for hours, you would notice that it is never completely still. It gently shimmers, not with violence, but with endless motion. Now imagine drawing closer still. The warmth becomes more noticeable, not uncomfortable. Simply comforting, like standing beside a fireplace on a cool evening. Golden light surrounds us from every direction. Unlike the light of a lamp, sunlight feels rich and alive. Each tiny beam has traveled an astonishing journey before reaching us. Many people imagine that sunlight begins at the surface of the sun, but that is only the final step. The energy creating this gentle glow actually began deep inside the star, where unimaginable pressure quietly transforms hydrogen into helium. The light we see today may have started its journey hundreds of thousands of years ago. Only after wandering through countless collisions inside the sun did it finally escape into space. Then, after leaving the surface, it traveled across nearly 150 million kilometers in just over 8 minutes before reaching Earth. Every sunrise is the final chapter of a story that began long before human civilization. Perhaps even before the first modern humans walked the earth. There is something deeply peaceful about that thought. The sunlight warming your face this morning began its life inside a star long before anyone could have witnessed it. As we continue approaching, another remarkable detail becomes visible. The edge of the sun does not appear perfectly smooth. Great arches of glowing plasma rise gracefully above the horizon. Some stretch tens of thousands of kilometers into space. Others reach even farther, tracing invisible magnetic pathways that curve elegantly before returning to the surface. From Earth, these structures can only be seen during special observations. From here, they resemble luminous bridges suspended above a sea of golden fire. They move slowly, almost gracefully. There is no sound, no crackling flames, no roaring furnace. Although the sun is unimaginably energetic, space itself carries no sound waves. Its magnificent activity unfolds in complete silence. Imagine watching a campfire that makes no noise at all. Its flames would seem strangely dreamlike. That is what the sun is like from nearby, a silent ocean of light. As we drift along its glowing horizon, dark patches slowly come into view. At first they appear almost black, but this is only because the surrounding surface is so brilliantly bright. These are sunspots. They are not holes. They are regions where powerful magnetic fields reduce the flow of heat rising from below. Even these cooler areas remain astonishingly hot, around 4,000 degrees Celsius, hot enough to melt almost anything we know on Earth. Yet beside the rest of the sun's surface, they appear surprisingly dark. Some sunspots are larger than our entire planet. Imagine placing Earth inside one of these quiet shadows. Our world would vanish almost completely. The scale of a star is difficult for the human mind to truly grasp. Everything here feels larger than imagination itself. And yet, despite its immense size, the sun is considered only an average star. Across our galaxy exist stars hundreds of times wider, thousands of times brighter, and millions of times more luminous. Still, for us, this gentle yellow star is perfectly enough. It has remained remarkably stable for billions of years. Without that stability, life on Earth might never have had the chance to grow. As we glide just above its radiant surface, we begin to sense that this is only the beginning. The glowing layer before us is merely the outer skin of something far more extraordinary. Beneath this brilliant light lie immense rivers of flowing plasma, slow-moving currents carrying unimaginable amounts of energy. And deep below those hidden layers, the quiet heart where every ray of sunshine is born. Taking one final peaceful breath, we prepare to leave the familiar surface behind and gently descend into the living interior of a star. The brilliant horizon now fills our entire view. There is no longer any sign of distant space ahead, only light, soft, golden, endlessly alive. We have arrived at the visible surface of our star. Astronomers call this layer the photosphere, a name that simply means the sphere of light. It is the part of the sun that shines toward the planets, the part that paints every sunrise, the part that warms forests after winter and turns quiet mornings into bright new days. Yet the word surface can be a little misleading. When we think of a surface, we imagine something solid. A beach beneath our feet, a quiet field, or smooth stone warmed by afternoon sunlight. A star has none of those things. There is no solid ground here, no rocky landscape waiting beneath the light. Instead, imagine standing above an endless ocean. Now replace the water with glowing plasma. That is much closer to reality. Plasma is often called the fourth state of matter. Most things around us are solids, liquids, or gases. Ice becomes water. Water becomes steam. But if enough energy is added, something extraordinary happens. The atoms themselves begin to change. Electrons break free from their tiny homes around atomic nuclei. Matter becomes electrically charged. It glows. It flows. It responds to invisible magnetic fields. This remarkable substance is plasma. Nearly everything inside a star exists in this state. In fact, most of the visible universe is made of plasma. The stars above us, the glowing clouds inside distant nebulas, even the beautiful curtains of Earth's northern lights are all forms of this extraordinary material. Our own planet, is actually the unusual place. Solid worlds like Earth are comparatively rare. The universe itself is largely a universe of glowing plasma. As we drift only a short distance above the photosphere, its texture becomes increasingly beautiful. What looked smooth from millions of kilometers away now resembles a vast golden mosaic. Everywhere we look are softly glowing cells, bright centers surrounded by darker edges. Each one slowly changes shape before quietly fading away. From this distance, they almost resemble the gentle bubbles forming in fresh bread dough as it slowly rises. Or perhaps clouds drifting across a peaceful summer sky. Nothing appears rushed. Nothing feels chaotic. Everything moves with surprising grace. These glowing cells are called granules. Each granule is a giant column of hot plasma rising upward from deeper inside the sun. As it reaches the surface, it begins to cool ever so slightly. Then gravity gently pulls it back downward along the darker edges before the cycle quietly begins again. One granule lives only for about 10 to 20 minutes. Then another forms nearby. The entire surface is constantly renewing itself. If you could somehow watch the sun safely for several hours, it would seem almost alive, like breathing, like countless slow waves rolling across an endless golden sea. Each granule may appear small from here, yet appearances can be wonderfully deceptive. Many are nearly 1,000 kilometers across. Some stretch even farther. Several Earths could fit comfortably inside the largest groups of granules. It is another reminder that stars exist on scales our everyday experience can barely imagine. Now imagine gently lowering yourself a little closer. The brightness becomes richer. The golden light surrounds us completely. If light had a texture, perhaps it would feel like this: soft, warm, weightless. There are no flames reaching upward as we see in an ordinary fire. Fire on Earth depends upon oxygen. The sun burns in a completely different way. There is no wood, no fuel being consumed by ordinary flames. Instead, the glowing plasma itself creates this magnificent brilliance. Every atom contributes to the light. Every particle becomes part of an immense luminous ocean. Far above the photosphere lies another mysterious layer called the corona. Curiously, the corona is much hotter than the visible surface below it. For many years, this puzzled scientists. How could the outer atmosphere become hotter than the layer beneath it? Even today, researchers continue studying this fascinating mystery. Powerful magnetic fields appear to play an important role, quietly transferring energy into the sun's outer atmosphere through processes that are still being explored. The universe, it seems, always keeps a few beautiful secrets. As we continue floating above the surface, delicate loops of glowing plasma begin rising gracefully into space. Some arch high above us before gently curving back toward the sun. Others stretch astonishing distances across the solar atmosphere. These glowing bridges are shaped by magnetic fields that remain completely invisible. We cannot see the magnetic lines themselves, only the luminous plasma tracing their graceful paths. It is rather like watching leaves drift along an unseen current in a quiet stream. The current remains hidden, yet its shape becomes visible through everything it gently carries. Even here, where temperatures reach about 5,500 degrees Celsius, there is an unexpected sense of order. The sun is not random. It follows elegant physical laws that have remained unchanged for billions of years. Gravity, magnetism, pressure, energy, each quietly balancing the others, each playing its part in a cosmic harmony far older than our world. Take another slow breath. Notice how peaceful everything feels despite the unimaginable power surrounding us. The sun does not struggle to shine. It simply does. Every second, it transforms hundreds of millions of tons of hydrogen into helium, releasing extraordinary amounts of energy. And yet, from here, its light feels gentle, its movements graceful, its presence reassuring. Soon, we will leave this beautiful ocean of golden plasma behind. Our journey will take us beneath the glowing photosphere, into a hidden region where immense rivers of plasma slowly rise and fall like the tides of an invisible sea. There, the quiet circulation of a star begins. With quiet curiosity, we now leave the brilliant photosphere behind. There is no doorway, no sudden change, only a slow and graceful descent into a world that no human eye has ever truly seen. The golden light above us becomes softer. The familiar patterns of the surface gradually fade. Ahead lies a region hidden beneath the sun's glowing skin, a place known as the convection zone. If the photosphere is the face of a star, then the convection zone is its slow and steady heartbeat. Imagine standing beside a calm ocean just before sunrise. Long, gentle waves rise from deep below before quietly returning to the sea. Now replace that water with glowing plasma. Stretch those waves until each one is wider than Earth. Slow them down until a single journey takes weeks or even months. That is the remarkable rhythm of the convection zone. Here, nothing happens quickly. Although temperatures remain unimaginably hot, the movement itself is surprisingly patient. Deep below us, plasma absorbs tremendous amounts of energy flowing outward from the heart of the sun. As it warms, it becomes slightly less dense than the plasma surrounding it. Very slowly, it begins to rise, not because anything pushes it, simply because warmer material naturally floats above cooler material. It is the same gentle principle that allows warm air to rise above a campfire on Earth. Or the same reason bubbles slowly climb through a pot of gently simmering soup. Nature often repeats the same simple ideas, only on vastly different scales. Here inside the sun, those familiar motions become truly enormous. Each rising column of plasma may stretch hundreds of thousands of kilometers. Some convection currents are wider than entire planets. Yet despite their immense size, they move almost peacefully. If you could somehow remain here for only a few seconds, nothing would seem to happen at all. The movement is simply too slow for human eyes to notice. But if you could watch for days or weeks, you would begin to see the quiet circulation unfolding around you. Great rivers of glowing plasma steadily climbing upward, cooling slightly near the surface, then gently sinking back into the depths. It is a never-ending cycle. There is no beginning, no final destination, only continuous motion, like breathing. or the slow circulation of Earth's oceans. This quiet circulation carries an extraordinary responsibility. It transports the energy created deep within the sun's core toward the visible surface. Without these gentle currents, sunlight could never reach space. Every warm afternoon, every sunrise reflecting across a quiet lake, every golden autumn evening depends upon these hidden rivers flowing patiently beneath our feet. Take a moment to imagine their scale. On Earth, the largest rivers stretch for thousands of kilometers. The Amazon, the Nile, the Yangtze. Here inside the sun, those mighty rivers would seem like tiny streams. The convection currents surrounding us are almost beyond imagination. Some could easily swallow entire worlds while continuing their slow journey upward. Yet despite this unimaginable size, everything feels strangely calm. There is no violence, no crashing waves, only smooth motion guided by gravity and heat. Every particle follows the same quiet laws of physics that shape clouds drifting across Earth's skies. Perhaps that is one of the most beautiful truths about the universe. The same forces that lift steam from a warm cup of tea also guide the movement of matter inside a star. Nature does not invent new rules for larger places. It simply repeats familiar patterns on grander and grander scales. As we drift deeper into this glowing sea, the light changes. Above us, the photosphere shines like a distant golden ceiling. Below, the plasma grows brighter, warmer, denser. Its soft orange glow slowly deepens toward brilliant white. Every direction is filled with flowing light. There is no horizon anymore, only an endless living ocean. Occasionally, immense currents pass quietly nearby. They move so slowly that they almost resemble floating clouds. Yet each one contains more material than entire mountain ranges on Earth. Their graceful motion reminds us once again that stars experience time differently than we do. What feels almost motionless to us is part of a magnificent circulation that has continued without interruption for billions of years. Some scientists compare the convection zone to a giant pot of gently boiling water. The comparison is helpful, but only to a point. A kitchen pot is noisy, restless, filled with bursting bubbles. The sun is different. Its movements unfold across such enormous distances that everything feels graceful instead of frantic. The universe often becomes calmer, not because less is happening, but because the scale becomes so immense. Now, as we continue our peaceful descent, the plasma around us grows increasingly dense. The gentle currents become more difficult to distinguish. The sunlight surrounding us begins to soften into a rich amber glow. Ahead lies another mysterious region. A place where the great rivers of plasma gradually disappear, where energy no longer travels by flowing currents, but by something even more extraordinary. Soon, we will enter the radiative zone, where a single particle of light may wander for hundreds of thousands of years before finally escaping into the universe. As we continue our gentle descent, the great rivers of plasma slowly fade behind us. The graceful currents that carried warmth toward the surface become quieter until they seem to disappear altogether. We have entered another hidden world, a place unlike any other inside the sun. Astronomers call it the radiative zone, Its name sounds technical, yet its story is wonderfully simple. Here, energy no longer travels by flowing rivers of plasma. Instead, it moves as light, not the bright golden sunlight we know on Earth, but tiny packets of energy called photons. Imagine holding a single grain of golden dust. Now imagine that tiny grain is actually a particle of light, invisible, weightless, moving at nature's fastest possible speed. This tiny traveler begins its remarkable journey deep inside the sun. And what happens next is one of the most astonishing stories in all of science. At first, we might expect that light races straight toward the surface. After all, light moves at nearly 300,000 kilometers every second. It circles Earth more than 7 times in a single heartbeat. Surely escaping the sun should take only moments. But inside a star, nothing is that simple. The radiative zone is incredibly dense, far denser than anything we experience on Earth. Imagine standing inside an enormous forest. The trees are packed so closely together that there is almost no empty space. Every step forward ends almost immediately as another tree blocks your path. Now imagine that forest becoming even denser. Billions upon billions of trunks packed together. That begins to resemble what a photon experiences here. The light cannot simply fly outward. Almost immediately, it collides with another particle. The photon disappears. A fraction of a moment later, a new photon is emitted, perhaps in the same direction, perhaps in a completely different one. Forward, backward, sideways. There is no predictable path. This process repeats again, and again, and again, trillions upon trillions of times. Scientists sometimes describe this as a random walk. It is almost like watching someone wander through a giant maze while blindfolded. Each step is chosen at random. Sometimes they move closer to the exit. Sometimes they accidentally walk farther away. Eventually, after an unimaginably long journey, they find their way out. That is exactly what happens to light inside the sun. Although every tiny movement occurs at the speed of light, the endless collisions slow the overall journey enormously. A photon born near the sun's core may require not minutes, not days, not centuries, but perhaps hundreds of thousands of years before finally reaching the visible surface. Some scientific models suggest even longer journeys under certain conditions. Pause for a moment and let that sink in. The sunlight warming your skin this afternoon may have begun its journey before modern humans existed, perhaps before the first paintings appeared inside ancient caves. Long before history was ever written, every beam of sunlight carries extraordinary patience. As we drift peacefully through the radiative zone, imagine countless invisible travelers surrounding us, each one quietly bouncing from particle to particle. None of them knows where the surface lies. None of them follows a straight path. Yet together, they slowly carry the enormous energy produced deep inside the sun outward toward space. It is almost like millions of people passing a tiny glowing lantern through an endless crowd. One person gently hands it to another, then another, then another. No single traveler crosses the entire distance. Yet eventually, the light reaches its destination. Nature often solves enormous challenges through countless tiny steps. The radiative zone reminds us of something surprisingly comforting. Progress does not always happen quickly. Sometimes the universe itself advances one tiny step at a time, slowly, patiently, without ever stopping. Around us, everything glows with a rich golden white light. The plasma here is so compressed that individual currents are no longer visible. Instead, the sun feels solid, not because it truly is, but because the particles are packed together with incredible density. Temperatures remain astonishingly high, several million degrees Celsius. Pressure continues increasing as we descend deeper. If mountains could somehow exist here, they would be flattened instantly beneath the tremendous weight above them. Every layer of the sun presses gently downward. Gravity never sleeps. It quietly squeezes the star every second of every day. And yet, the sun does not collapse. Something equally powerful pushes back. We have not quite reached that place yet. But far below us, at the very center, a quiet process is unfolding. Tiny hydrogen atoms are joining together. Minute amounts of matter are becoming pure energy. That gentle transformation supports the weight of an entire star. Without it, the sun would slowly shrink beneath its own gravity. With it, the balance has lasted for nearly 4.5 billion years. The deeper we travel, the brighter everything becomes. The light around us no longer seems to come from any single direction. It surrounds us completely. There are no shadows here. Only a peaceful brilliance filling every corner of this hidden world. Ahead, the density increases once more. The temperatures continue climbing. Gravity grows stronger with every quiet mile. Soon, we will reach the very heart of the sun, the ancient furnace where every sunrise, every warm breeze, every green leaf, and every ray of sunlight first begins. Our journey toward the quiet center is almost complete. Our journey has been long. We have drifted across the glowing surface, passed through the vast convection zone, wandered among countless patient photons inside the radiative zone, and now, at last, we arrive at the center of the sun, the core. If the sun were a living heart, this would be the place where every pulse begins. There is no grand chamber waiting for us. No glowing crystal, no blazing furnace with towering flames. Instead, the very center of a star is surprisingly calm. Not calm because little is happening, but because everything has found perfect balance. Around us, the pressure is almost impossible to imagine. Above our heads rests nearly the entire mass of the sun. Every layer, every glowing ocean of plasma, every brilliant wave of light, all gently pressing downward. Gravity has gathered this enormous star together for billions of years. At the core, that weight becomes extraordinary. If mountains existed here, they would vanish instantly. If steel somehow survived this far, it would flow like warm honey. Matter itself behaves differently under such immense pressure. The temperature reaches nearly 15 million degrees Celsius, hotter than any fire ever created on Earth. Yet strangely, the heat is not the most remarkable thing here. The pressure is. Imagine holding two tiny magnets. As you push them together, they naturally resist. Atomic nuclei behave in a similar way. Each hydrogen nucleus carries a positive electric charge. Positive charges naturally repel one another. Under ordinary conditions, they never come close enough to touch. Even inside the hottest flames on Earth, hydrogen atoms simply bounce apart. But here, the story changes. Gravity quietly squeezes the sun from every direction. Little by little, the hydrogen atoms are forced closer together. Closer, closer still, until something extraordinary happens. The immense pressure allows the nuclei to approach so closely that another force begins to take over. A force far stronger than electrical repulsion, the strong nuclear force. It acts only across unimaginably tiny distances. Normally, its reach is far too short. But here in the sun's core, gravity gently brings the hydrogen nuclei close enough for this hidden force to do its work. And in that quiet instant, two tiny hydrogen nuclei become one. Not with an explosion, not with a violent flash, but through an elegant transformation that scientists call nuclear fusion. It is one of the most beautiful processes in nature. Tiny particles quietly joining together, creating something new. Over several gentle steps, for hydrogen nuclei are ultimately transformed into one helium nucleus. Along the way, a tiny amount of matter disappears. At least, it appears to. Nothing is truly lost. Instead, that missing matter becomes pure energy. More than a century ago, Albert Einstein described this relationship with perhaps the most famous equation in science. E equals mc squared. A small amount of mass can become an astonishing amount of energy. Inside the sun, this equation quietly comes to life every second. About 600 million tons of hydrogen take part in fusion every single second. That number sounds almost unimaginable. Yet because the sun is so enormous, it has enough hydrogen to continue shining for billions more years. Of those 600 million tons, roughly 596 million tons become helium. The remaining 4 million tons become energy. Just 4 million tons. Compared with the sun's total mass, it is almost nothing. Yet that tiny fraction is enough to illuminate an entire solar system. It warms Earth's oceans, drives the winds, feeds the forests, powers every green leaf through photosynthesis, and ultimately supports nearly every form of life our planet has ever known. Pause for a moment and imagine that. Every bird singing at sunrise, every tree quietly growing, every field of golden wheat, every breath you have ever taken can trace its energy back to these tiny fusion reactions unfolding silently beneath us. The core asks for no recognition. It shines without celebration. It simply continues its ancient work, second after second, century after century, billion after billion of years. Around us, countless fusion reactions occur every moment, not randomly, not chaotically, but with remarkable consistency. The sun has become an expert at patience. It never burns all its fuel at once. It releases energy gradually, steadily, almost gently. That quiet steadiness is precisely what makes life on Earth possible. If the sun released all its energy in one brilliant instant, our solar system would never have known peaceful mornings. Instead, its light arrives little by little, day after day, season after season, age after age, As we float peacefully within the heart of the star, we begin to understand something profound. The sun is not merely burning. It is creating balance. Gravity pulls inward. Fusion pushes outward. Neither side wins. Neither side loses. Together, they create a harmony that has endured for almost 4.5 billion years. This invisible balance is one of the greatest acts of quiet engineering in the universe. And it all begins here, in this peaceful heart of light. Soon, we will discover how this newly created energy starts its impossibly long journey toward the surface. A journey that may last hundreds of thousands of years before becoming the gentle sunshine that someday touches your face. For countless ages, deep within the quiet heart of the sun, hydrogen has been gently becoming helium. Tiny amounts of matter have become extraordinary amounts of energy. Now, a new chapter begins. Our attention turns from the creation of energy to the remarkable journey it must undertake. Imagine, for just a moment, that you could become one tiny particle of light, a single photon, smaller than anything you could ever see, without weight, without age, existing only as pure energy. Your story begins here, inside the peaceful core of a star. You are born in an instant. One moment you do not exist. The next, you are racing through the glowing interior at the fastest speed the universe allows. To you, there is no effort, no decision. Traveling at the speed of light is simply your nature. Surely, you will reach the surface in moments, or so it seems. But almost immediately, your journey changes. Only a tiny fraction of a centimeter from where you were born, you meet another particle. The collision is gentle. There is no explosion, no dramatic flash. Your energy is absorbed. For an unimaginably brief instant, you are gone. Then, almost immediately, a new photon appears. It carries nearly the same energy, yet it is not traveling where you were going. Instead, it heads in a completely different direction, perhaps upward, perhaps sideways, perhaps even deeper toward the center of the sun. This happens again, and again, and again. Each collision lasts almost no time at all. Yet together, they transform what should have been an 8-minute journey into one lasting hundreds of thousands of years. It is difficult for the human mind to imagine patience on such a scale. Civilizations rise and fall. Mountains slowly erode. Ice ages come and go. Entire species appear and disappear. Meanwhile, one tiny packet of sunlight continues wandering through the sun, still searching for the surface, still quietly bouncing from atom to atom. Every collision changes the photon's direction. Sometimes it accidentally moves closer to freedom. Sometimes it drifts farther away. There is no map, no guide, only chance. Scientists describe this as a random walk. Imagine standing in the center of a vast snowy field during a gentle evening fog. You cannot see the edge. Each step is chosen completely at random. One step north, 2 steps east, 1 step back, 3 steps west. Eventually, after enough wandering, you will reach the edge, not because you followed the perfect path, but simply because you never stopped moving. The photon experiences something very similar. Its journey is not fast because the sun prevents light from moving quickly. The photon itself always travels at light speed. Instead, it is constantly interrupted, its path broken into countless tiny pieces. Imagine trying to cross a crowded room where every person gently stops you for a brief conversation. Each individual pause is almost meaningless. Yet together, they turn a short walk into a very long evening. Inside the sun, nature performs this quiet dance trillions upon trillions of times. Every second, new photons begin their patient journey. Others finally escape. Still others remain deep inside, continuing a voyage that began long before the first human ever looked toward the sky. The sunlight reaching your face today may have started its life before the earliest cities were built, perhaps before Stonehenge, perhaps before agriculture, perhaps even earlier. Every sunrise carries echoes of an unimaginably distant past. There is something deeply comforting in that thought. The light arriving tomorrow morning has already spent ages preparing for its journey. Nothing about it is hurried. Nothing is rushed. The universe seems wonderfully content to let beautiful things take time. As we float among these invisible travelers, the radiative zone glows softly around us. Countless photons quietly weave their unpredictable paths, each one carrying a tiny piece of the sun's enormous energy. No single photon lights the earth. No single photon warms an ocean. But together, they create daylight itself. Nature rarely depends upon one great miracle. Instead, it builds extraordinary beauty from countless tiny contributions. One photon, one atom, one quiet step after another. Perhaps life itself follows the same gentle pattern. The smallest moments, repeated patiently over time, can create something magnificent. Above us, the distant surface still lies far away. Below, the quiet heart of the sun continues creating fresh energy every passing second. The journey never truly ends. As old photons finally escape into space, new ones quietly begin their own ancient voyage. The sun is constantly renewing itself, never exactly the same, yet always familiar, always dependable, always patient. Soon, we will discover how these countless travelers finally reach the photosphere, where, after an unimaginably long journey through the interior, they are released into the vast silence of space. From there, their final destination may become a blue world orbiting quietly 93 million miles away. A world where one gentle ray of sunshine might someday warm your face on a peaceful morning. Our peaceful journey now brings us to one of the greatest miracles in the universe. It is not a place you can touch, not a glowing chamber hidden inside the sun, not a mysterious object waiting to be discovered. Instead, it is a balance. An invisible agreement between two powerful forces. Without this quiet harmony, no star could shine, no planet could enjoy gentle mornings, no life would ever have the chance to exist. Take a slow breath and imagine the sun holding perfectly still before us. From the outside, it appears calm, steady, almost unchanging. Day after day, year after year, century after century. Yet hidden beneath that peaceful appearance, two enormous forces are quietly competing every single second. The first is gravity. Gravity is wonderfully patient. It never becomes tired. It never stops pulling. From the moment the sun first formed from a great cloud of hydrogen gas, gravity began drawing every tiny particle toward the center. Even now, gravity continues its gentle work. Every atom inside the sun feels that invisible pull. Every layer presses downward. Every glowing ocean of plasma slowly adds its weight to the layers below. If gravity were the only force at work, the story would be very short. The sun would simply continue shrinking, smaller, denser, hotter, until it collapsed completely beneath its own enormous weight. But something quietly resists. Deep inside the core, where we recently watched hydrogen become helium. Nuclear fusion creates far more than light. It also creates pressure. Every fusion reaction releases energy in all directions. That energy pushes outward, not violently, not suddenly, simply steadily. Imagine placing your hands together. Your left hand gently pushes to the right. Your right hand gently pushes to the left. Neither hand wins. Neither hand loses. Instead, they remain perfectly balanced. That simple image captures one of the greatest secrets of every ordinary star. Gravity pulls inward. Fusion pushes outward. The balance between these two forces has a special name. Astronomers call it hydrostatic equilibrium. The words sound complicated, but the idea is beautifully simple. A star survives because it is always balancing these two quiet partners. Too much gravity, the star shrinks. Too much outward pressure, the star expands. For billions of years, our sun has maintained this delicate harmony with astonishing precision. It is almost like watching an expert dancer balancing effortlessly upon one foot. Tiny adjustments happen continuously, yet the overall movement appears calm. Imagine balancing a feather upon your fingertip. Every tiny movement of your hand keeps the feather upright. The balance is always changing, yet it somehow remains stable. The sun performs a similar dance. Every second, every minute, every year, for billions of years. This remarkable stability is one reason life has flourished on Earth. Our sun does not suddenly become twice as bright one morning, nor does it fade away without warning. Instead, its light changes only very slowly across immense stretches of time. The forests, the oceans, the birds, the flowers, and every living creature have quietly depended upon that steady rhythm. Even your own heartbeat owes something to this ancient balance. The food you eat grows because sunlight feeds green plants. Those plants capture the sun's energy through photosynthesis. Animals eat the plants. People eat both plants and animals. Every heartbeat becomes part of a chain that begins here. Inside this peaceful star, there is something wonderfully comforting about that connection. The warmth of your morning coffee, the fragrance of fresh grass after rain, the quiet shade beneath an old oak tree. All are distant gifts from the balance unfolding inside the sun. As we float quietly within the core, we begin to notice another beautiful truth. The sun is not fighting gravity. Gravity is not the sun's enemy. Without gravity, fusion would never begin. Without fusion, gravity would never be balanced. Each force depends upon the other. Together, they create something neither could achieve alone. Nature often works this way. Opposites do not always compete. Sometimes they cooperate. Sometimes balance becomes more important than victory. Perhaps that is one of the quiet lessons hidden inside the stars. Strength is not always found in overpowering something else. Sometimes, strength is found in harmony. Around us, fusion continues without interruption. Millions upon millions of tiny reactions quietly release fresh energy every second. The pressure they create gently supports the unimaginable weight above. The sun breathes, not with air, but with physics itself. Above us, that energy begins another impossibly long journey through the radiative zone. Eventually, after wandering for hundreds of thousands of years, it will reach the glowing photosphere. From there, it will cross the silent emptiness of space in just 8 minutes. Some of those photons may fall upon a quiet forest. Others may sparkle across an ocean. Some may warm the face of a sleeping child beside a sunny window. And some may one day reach you, all because gravity and light have quietly remained in perfect balance for billions of years. As we prepare to leave the peaceful core behind, another fascinating traveler is already racing outward. Unlike photons, it will not spend hundreds of thousands of years escaping. It will pass almost effortlessly through the sun, through space, through Earth itself, invisible, silent, almost impossible to stop. Its journey has already begun. Our journey remains deep inside the peaceful heart of the sun. Around us, countless fusion reactions continue their quiet work. Hydrogen gently becomes helium. Energy is born. Photons begin their impossibly long wander toward the surface. But photons are not the only travelers created here. There is another visitor. One so mysterious that trillions of them are passing through your body right now, without leaving even the faintest trace. They are called neutrinos. Their name comes from an Italian word meaning little neutral one. It is a fitting description. Neutrinos carry no electric charge. They are astonishingly light. For many years, scientists even wondered whether they had any mass at all. Today we know they do possess a tiny amount, so small that measuring it remains one of modern physics' greatest challenges. If photons are patient travelers, neutrinos are fearless explorers. The moment a fusion reaction occurs, a neutrino is born. Unlike photons, it does not become trapped inside the sun. It does not collide endlessly with surrounding particles. Instead, it simply leaves. Imagine trying to walk through an enormous crowd. Every few steps, someone gently stops you. That is the experience of a photon. Now imagine walking through the very same crowd. Yet every person becomes transparent as you approach. You pass through effortlessly, never slowing down. That is much closer to the journey of a neutrino. Matter hardly notices that it exists. The sun itself cannot hold it. Almost the instant it is created, the neutrino begins racing outward at nearly the speed of light. In less than 3 seconds, it escapes the sun completely. Compare that with the patient photon, which may spend hundreds of thousands of years wandering through the stellar interior before reaching the same destination. Two travelers, born together, experiencing entirely different journeys. Once free of the sun, the neutrino enters the vast silence of space. There are no roads, no signs, no destination markers, only endless darkness sprinkled with stars. Yet it never hesitates. It simply continues forward. About 8 minutes later, many of these tiny travelers arrive at Earth. Every second, around 60 to 70 billion solar neutrinos pass through every square centimeter of your body. Pause for a moment. That means countless invisible visitors have already passed through your hands, your heart, your eyes, even as you listen to these words. And you never notice. Neither does the Earth. Most neutrinos continue straight through our entire planet as though it were almost empty space. Some enter through the daylight side of Earth, travel completely through its rocky interior, cross thousands of kilometers of solid iron and stone, then quietly emerge on the opposite side without changing direction. To a neutrino, an entire planet is surprisingly transparent. This remarkable ability made neutrinos incredibly difficult to discover. Scientists first predicted their existence in the 1930s, yet proving they were real required extraordinary patience. Researchers built enormous underground laboratories beneath mountains and inside deep mines. Why underground? Because layers of rock shielded the instruments from most other particles arriving from space. Deep below the surface, sensitive detectors waited quietly. Sometimes they contained vast pools of ultra-pure water. Others used special transparent liquids designed to capture the faintest possible signal. For weeks, months, even years, scientists simply waited. Most neutrinos pass straight through without interacting. But every once in a great while, one would gently collide with an atom. Just once. That tiny interaction produced a delicate flash of light, a whisper from the heart of the sun. Those faint flashes confirmed something extraordinary. The fusion reactions powering our nearest star were truly happening exactly as scientists had imagined. In a sense, neutrinos allow us to look directly into the sun's core. Photons cannot do that. By the time sunlight reaches us, it has wandered through the star for hundreds of thousands of years. Neutrinos, however, arrive only minutes after they are created. They carry fresh news from the very center. Tiny cosmic messengers, reporting directly from the birthplace of sunlight. Perhaps there is something quietly beautiful about that. The universe has many voices. Some speak through light, others through gravity, and some whisper through particles so elusive that an entire planet can barely slow them. As we drift peacefully inside the sun, imagine these invisible travelers surrounding us. Every second, countless neutrinos quietly depart. They spread across the solar system like silent ambassadors. Some continue beyond Earth forever. Some pass between distant planets. Some leave our galaxy entirely. They may wander the universe for billions of years, never stopping, never growing tired, carrying with them a tiny memory of the star where they were born. Around us, the core continues its patient work. Gravity still presses inward. Fusion still shines outward. Photons continue their slow and ancient pilgrimage. Neutrinos continue their effortless escape. Every part of the sun performs its own quiet task. Together, they create the steady light that has gently watched over Earth since long before life first appeared. Soon, we will begin our own journey back toward the outer layers of the star. There, We will discover why the sun's glowing surface is only the beginning of an even larger and more mysterious atmosphere, one that stretches millions of kilometers into space like a luminous golden crown. Very gently, we begin rising away from the quiet heart of the sun. Behind us, the fusion reactions continue their ancient work. Photons remain on their patient journeys. Neutrinos race effortlessly into space. Nothing has stopped. Nothing has changed. The great engine inside the star simply continues, exactly as it has for billions of years. As we slowly pass once again through the radiative zone, and then through the immense convection currents, the familiar golden light gradually grows brighter. Ahead, the photosphere returns. Its softly glowing granules spread across the horizon like an endless sea of liquid gold. We drift upward. Then, without noticing a clear boundary, we quietly leave the visible surface behind. Most people imagine that the sun ends here. After all, when we look upward from Earth, the bright yellow disk appears to have a clear edge. But that edge is only an illusion. A star does not simply stop. Beyond the photosphere lies another remarkable world, a vast atmosphere extending millions of kilometers into space. The first layer is called the chromosphere. Its name means sphere of color. Normally, this delicate region remains hidden beneath the overwhelming brightness of the photosphere. Only during a total solar eclipse, when the moon perfectly covers the sun's brilliant face, does the chromosphere briefly reveal itself. For a few precious moments, observers see a thin ribbon of glowing crimson light surrounding the dark silhouette of the eclipsed sun. It is one of nature's most peaceful spectacles. Imagine standing beneath a warm summer sky. Daylight slowly fades. Birds grow quiet. The moon glides gently across the sun. Then, just before complete darkness, a delicate ring of ruby red light appears. For countless generations, people witnessed this breathtaking sight without understanding what it truly was. Today, we know we are seeing the hidden atmosphere of a living star. As we continue drifting outward, the chromosphere stretches beneath us like a glowing ocean at sunset. Great fountains of plasma slowly rise from its surface. Some climb thousands of kilometers into space before gently falling back again. These graceful structures are known as spicules. From a distance, they resemble soft blades of glowing grass swaying in a silent breeze. Each one lasts only a few minutes, yet at any given moment, millions of them quietly decorate the sun. Together, they constantly lift hot plasma upward into the outer atmosphere. No one completely understands every detail of how they form. Like many parts of the universe, they still keep some of their secrets. Perhaps that is fitting. The cosmos always leaves us something new to wonder about. Now, our journey carries us even farther from the visible surface. The golden glow gradually softens. The surrounding space becomes darker once again. Yet something extraordinary appears before us, stretching outward in every direction. Far beyond the edge of the sun is a magnificent halo of pale white light. Delicate, ghostly, almost ethereal. This is the corona, the sun's outer atmosphere, its luminous crown. During a total solar eclipse, The corona becomes visible as shimmering white streamers extending gracefully into space. Many people describe it as one of the most beautiful sights they have ever witnessed. From nearby, its beauty becomes even more astonishing. Long ribbons of glowing plasma stretch millions of kilometers from the sun. Some curve elegantly before returning to the surface. Others extend so far that they slowly merge with the endless darkness of space. Everything feels calm, weightless, timeless. Yet the corona hides a remarkable mystery. The visible surface of the sun is about 5,500 degrees Celsius. Common sense suggests that moving farther away should make things cooler. Instead, the opposite happens. The corona reaches temperatures of more than 1 million degrees Celsius. For decades, this puzzled astronomers. How could the outer atmosphere become hundreds of times hotter than the surface below it? Even today, scientists continue exploring this fascinating question. The leading ideas point toward the sun's invisible magnetic fields. As those magnetic lines twist, stretch, and gently reconnect, they release enormous amounts of energy into the corona. Tiny events called nanoflares may occur throughout this region. Each one is far too small to notice by itself, but together, they may quietly heat the entire outer atmosphere. It is another reminder that great things are often built from countless tiny moments. The universe seems to enjoy that pattern. Around us, the magnetic fields become easier to imagine. We cannot see the fields themselves, but glowing plasma faithfully follows every invisible curve. Immense arches rise gracefully above us. Loops intertwine like luminous ribbons dancing through silent space. Nothing here appears hurried. Even the most energetic events unfold with remarkable elegance. As we continue floating through the corona, we notice something gently streaming away from the sun. It is almost impossible to see. A steady flow of charged particles, leaving the star forever. This quiet river never stops. Second after second, year after year, it spreads throughout the solar system. Astronomers call it the solar wind. Unlike the breeze you might feel on Earth, the solar wind is not made of moving air. It is composed of tiny charged particles, mostly protons and electrons, released from the sun's outer atmosphere. They travel outward at astonishing speeds. Some move at 400 kilometers every second. Others travel even faster. Within only a few days, many of them reach Earth. There, our planet's magnetic field gently guides them toward the polar regions. When these particles meet Earth's upper atmosphere, the sky quietly comes alive. Soft curtains of green, purple, pink, and red begin dancing across the darkness. The beautiful auroras, known as the northern and southern lights, are among the solar wind's most graceful gifts. Imagine standing beneath a frozen Arctic sky. The air is perfectly still. Snow softly covers the ground. Then, without sound, the heavens begin flowing with waves of emerald light. Gentle ribbons drift from horizon to horizon. The entire sky seems to breathe. Every shimmering curtain began its journey here, inside the peaceful atmosphere of a star. And now, as we float beside the sun's luminous crown, we understand that its influence extends far beyond its glowing surface. Its light, its magnetic fields, its gentle solar wind, all reach outward across the solar system, quietly shaping the worlds that orbit around it. Our journey, however, is far from over. Soon, we will discover that not all stars are like our sun. Some are cool and dim, living for trillions of years. Others burn brilliant blue, shining with breathtaking intensity before living surprisingly short lives. Among the stars, every light tells a different story. For a little while, let us gently leave our own sun behind. As we drift farther into the quiet darkness of space, its warm golden glow slowly becomes another peaceful point of light among countless others. From this distance, it looks almost ordinary, and in many ways, it truly is. Our sun is often called an average star, not because it is unimportant, but because the universe contains an astonishing variety of stars. No two live exactly the same life. Just as every tree in a forest grows differently, every star follows its own quiet path. Some are born small and patient. Others begin life with breathtaking brilliance. Some shine so gently that they may outlive the universe as we know it. Others blaze with such intensity that their entire lives pass in only a few million years. It all begins with one simple difference. Massachusetts, when a cloud of gas collapses under gravity, the amount of material gathered together determines almost everything that follows. A little more mass, a very different destiny. Imagine visiting one of the smallest stars in the galaxy. These peaceful little suns are called red dwarfs. From a distance, they glow with a warm reddish light, softer than our own Sunday. Their surfaces are much cooler. Their brightness is gentle. If you stood on a nearby planet, daylight might resemble an endless evening, filled with warm amber colors instead of brilliant yellow sunlight. Red dwarfs never hurry. Because they contain less mass, gravity presses less strongly upon their cores. Fusion proceeds slowly, very slowly. They use their hydrogen fuel with extraordinary care. If our sun is like a candle quietly burning through the night, a red dwarf is like a tiny lantern that refuses to go out. Many astronomers believe some red dwarfs may continue shining for trillions of years. That is difficult to imagine. The universe itself is only about 13.8 billion years old. Not one red dwarf has yet lived long enough to reach the end of its natural life. Every red dwarf ever born still exists today, somewhere, scattered across the Milky Way. Ancient little stars continue their patient work. They have witnessed galaxies changing shape. They have watched generations of larger stars appear and disappear, yet they quietly remain. Steady, faithful, unhurried. There is something comforting about such quiet endurance. Now, let us continue our journey toward another kind of star, one much larger than our sun. The darkness ahead slowly changes. A brilliant blue light begins to grow, even from an enormous distance. Its radiance is unmistakable. This is a blue giant. Everything about it feels larger, hotter, brighter. Its surface temperature may exceed 30,000 degrees Celsius, several times hotter than our own Sunday. The color tells the story. Stars are not blue because they contain different kinds of fire. They are blue because they are hotter, much hotter. Just as a piece of metal glows red before becoming white as it heats, Stars also change color with temperature. Blue stars represent some of the hottest places in the visible universe. Imagine standing near such a giant. The light would be dazzling. The surrounding space would glow with intense blue-white brilliance. Powerful ultraviolet radiation streams endlessly outward. Immense stellar winds race away from the surface, carrying enormous amounts of material into space. These magnificent stars are breathtaking, yet they possess one surprising weakness. They burn far too quickly, because gravity squeezes their cores so strongly. Fusion races ahead at an incredible pace. A blue giant may contain many times more fuel than the sun, yet it spends that fuel hundreds of times faster. Its brilliant life becomes unexpectedly short. Some survive only a few million years, compared with our sun's expected lifetime of about 10 billion years. That is almost the blink of an eye. The brightest stars often live the shortest lives. Nature sometimes reminds us that brilliance and longevity are not the same thing. Between these two extremes lie countless other stars. Orange stars, white stars, yellow stars like our own, each quietly finding its own balance between size, temperature, brightness, and time. Astronomers organize these different stars into what they call the stellar classification system. At first glance, it appears wonderfully simple. Stars are grouped according to their temperatures. The hottest belong to one family, the coolest to another. Long ago, the categories were given letters that still remain today. O, B, A, F, G, K, M. It may seem like a curious order, not alphabetical, not obvious, simply a historical arrangement preserved through generations of astronomy. Our own sun belongs to the G class, a comfortable middle ground, warm enough to support life, stable enough to shine steadily for billions of years. Not too large, not too small. Perhaps the universe quietly chose well. As we drift peacefully among these countless stars, one thought gently settles into the mind. The night sky is not filled with identical lights. Every point shining above us is an individual story, a different beginning, a different lifetime, a different ending. Some are newborn stars, just beginning to shine. Others are wise old suns approaching the twilight of their existence. Together, they fill the galaxy with a quiet diversity that is almost beyond imagination. And yet, no matter how different they appear, every star shares the same ancient purpose: to transform simple hydrogen into something richer, to fill the universe with light, and to create the elements from which future worlds, and perhaps future life, will someday emerge. Our own journey now continues toward another remarkable chapter. For even stars, as eternal as they may seem, do not shine forever. Like every story in the universe, their peaceful lives eventually change. Soon, we will witness how a familiar yellow star slowly grows old, expanding into one of the most beautiful sights in the cosmos. A gentle red giant glowing in the quiet darkness of space. Nothing in the universe lasts forever. Not mountains, not oceans, not galaxies, and not even the stars themselves. Yet the ending of a star is not something to fear. For many stars, growing old is one of the most beautiful chapters of all. As we continue our peaceful journey through the Milky Way, let us return to a familiar yellow star. Much like our own Sunday, it has spent billions of years quietly shining. Every second, its core has transformed hydrogen into helium. Every morning, its light has crossed space to warm the worlds nearby. Every season, life has flourished beneath its steady glow. But slowly, very slowly, something begins to change. Deep inside the core, the star notices that its greatest source of fuel is becoming scarce. Not all at once, not suddenly, simply little by little. After billions of years, much of the hydrogen at the very center has already been transformed into helium. The core grows richer in helium, poorer in hydrogen. Fusion begins to slow. As the outward pressure weakens, gravity quietly senses the opportunity. Patient as always, it gently squeezes the core once again. The core becomes smaller, denser, hotter. At first, this seems like the beginning of the end. But nature has another idea. As the center contracts, the layers of hydrogen surrounding the core become hot enough to begin fusion themselves. Instead of burning only at the very center, the star now develops a glowing shell where hydrogen continues quietly becoming helium. Surprisingly, this new shell produces even more energy than before. Far more. That additional energy begins pushing outward through the star. Not inward, outward. The outer layers slowly respond. They begin expanding, gentle at first, almost impossible to notice. But over thousands, then millions of years, the expansion continues. The star grows larger, and larger, and larger still. Imagine watching a tiny soap bubble slowly filling with warm air. It never bursts. It simply becomes wider and softer. That is very much how a sun-like star grows old. The outer atmosphere stretches farther into space. As it expands, its surface cools. This may seem surprising. After all, the star is producing enormous amounts of energy. Shouldn't it become hotter? The answer is beautifully simple. Imagine placing your hands near a small candle. The warmth feels concentrated. Now imagine spreading that same amount of warmth across an entire football field. Each individual place becomes cooler. The energy is now distributed across a much larger surface. The same thing happens to the aging star. Its enormous size allows the surface to cool from brilliant yellow to a warm orange, and eventually, a deep glowing red. The star has become a red giant. From a distance, it is breathtaking. Its soft crimson light fills the surrounding space with gentle warmth. The once modest yellow star now dwarfs its younger self. If our own sun eventually enters this stage, astronomers estimate its outer atmosphere will expand far beyond its present size. Mercury will almost certainly disappear. Venus will follow. The future of Earth remains a subject of scientific study, but the planet would almost certainly become completely uninhabitable long before the sun reached its largest size. Fortunately, this transformation lies about 5 billion years in the future, far beyond the lifetime of humanity as we know it today. There is no need for worry, only wonder, as we float beside this magnificent red giant. Its atmosphere feels remarkably delicate. Although the star has grown enormous, its outer layers have become surprisingly thin. Imagine stretching a small piece of dough until it becomes the size of a dinner table. It would grow thinner and softer. The same quiet principle applies here. The giant star is vast, yet much of its atmosphere is surprisingly diffuse. If you could somehow drift through portions of it, the glowing gas might feel almost like an extraordinarily gentle fog. Around us, the red giant glows peacefully. Its light has softened. Its heartbeat has slowed. There is a quiet dignity in its appearance. It is not fading away in sadness. It is simply entering another season of its life. Perhaps there is a lesson hidden here. Growing older does not always mean becoming weaker. Sometimes, it means becoming broader, gentler, more generous with the light we have spent a lifetime creating. The red giant now begins another remarkable task. Deep within its increasingly hot core, helium itself will soon become the next source of fuel. New fusion reactions will quietly begin, and with them, the star will create something the young universe once lacked: carbon, oxygen, and eventually, many of the elements from which planets, trees, animals, and people are made. The story of the universe has always been one of transformation. Hydrogen becomes helium. Helium becomes carbon. Carbon becomes life. Nothing is wasted. Everything becomes the beginning of something new. As we watch the peaceful red giant glowing against the darkness, its warm crimson light seems almost like the evening sky after sunset. Calm, beautiful, unhurried. Yet even this magnificent stage cannot last forever. The star still has one final gift to offer the universe. Soon, it will gently release its outer layers into space, creating one of the most delicate and colorful sights in all of astronomy. A glowing cloud of stardust, quietly drifting through the galaxy, preparing the ingredients for worlds that have not yet been born. Our peaceful red giant has reached the final chapters of its long and remarkable life. For billions of years, it has quietly illuminated its corner of the galaxy. It has transformed simple hydrogen into richer elements. It has patiently balanced gravity and light. Now, its work is almost complete. But before the star says its quiet farewell, it offers the universe one final gift, perhaps its greatest gift of all. As we drift beside the enormous crimson giant, its outer atmosphere becomes increasingly gentle. The star is now so large, and its outer layers so loosely held, that gravity can no longer keep everything together. Very slowly, almost imperceptibly, the outer gases begin drifting away. There is no violent explosion, no sudden destruction. Instead, imagine the petals of a flower slowly opening on a warm spring morning, or the soft seeds of a dandelion quietly floating into the breeze. That is much closer to reality. The star simply begins letting go. A little today, a little tomorrow, a little more over thousands of years. Gentle stellar winds carry glowing gas outward into the surrounding darkness. Hydrogen, helium, carbon, oxygen, and other precious elements quietly spread across space. The expanding cloud grows larger every century, then every millennium, then every age. From a distance, it begins to resemble a delicate bubble of glowing mist suspended among the stars. Astronomers call this beautiful structure a planetary nebula. The name is somewhat misleading. It has nothing to do with planets. Centuries ago, early telescopes showed these glowing clouds as small round disks that reminded observers of distant planets. The name remained, even after their true nature became understood. Today, we know they are among the most graceful creations in the universe. Imagine floating beside one. The surrounding darkness has become completely silent. Ahead, soft rings of emerald, turquoise, gold, rose, and violet slowly spread through space. The colors are not random. Each tells the story of a different element. Hydrogen often glows with gentle shades of red. Oxygen may shine green or blue. Other atoms add their own subtle colors to the expanding cloud. Together, they create celestial paintings unlike anything found on Earth. Some planetary nebulas appear perfectly round. Others resemble glowing butterflies with delicate wings stretching across space. Some form graceful hourglass shapes. Others create intricate spirals or luminous shells that seem almost handcrafted. Each one is unique. Each reflects the quiet personality of the star that created it. As sunlight from the tiny remaining core shines through these expanding gases, the cloud continues glowing for thousands of years. It becomes one of the galaxy's most peaceful works of art. Eventually, even this beauty slowly fades. The expanding gas becomes thinner, more transparent. It gently mixes with the surrounding regions of the Milky Way. Nothing disappears. Everything simply becomes part of something larger. The carbon released by one ancient star may someday become part of another. The oxygen drifting through this nebula may eventually join a newborn planet. The calcium floating quietly across space could one day become part of living bones. Even the iron moving through these glowing clouds may someday flow through the heart of a creature not yet imagined. The universe wastes remarkably little. Everything is recycled. Everything continues. Perhaps that is one of the most comforting ideas in astronomy. Stars do not simply end. They transform. The material they create becomes the beginning of future worlds. As we slowly drift through this glowing cloud, tiny grains of dust begin forming. These are not ordinary dust particles like those beneath a bookshelf. Each microscopic grain contains atoms forged during billions of years inside the heart of a star. Carbon crystals, silicate minerals, tiny solid fragments that slowly cool within the expanding nebula. Given enough time, gravity will gently gather some of this dust together with fresh clouds of hydrogen gas. A new stellar nursery may someday appear. Within it, another star will quietly be born, perhaps surrounded by planets. Perhaps one of those planets will develop oceans, clouds, mountains, forests, perhaps life. It is a beautiful cycle. Stars create the ingredients for planets. Planets create the conditions for life. Life looks upward and begins wondering about the stars. Around us, the planetary nebula continues expanding. Its colorful rings drift farther into the galaxy with every passing century. There is no sadness here, only quiet generosity. The old star has given everything it can, and in doing so, it has made countless future beginnings possible. At the very center of this glowing cloud, something small remains, brilliant, white, almost impossibly dense. Although the giant star itself has faded, its heart still survives. Tiny compared with the enormous red giant that came before, yet still quietly shining. This remarkable object, known as a white dwarf, will continue glowing gently for billions upon billions of years. And that will be the next peaceful chapter of our journey through the hidden lives of the stars. The colorful cloud surrounding us continues its graceful expansion. Its delicate ribbons of light drift farther into the galaxy with every passing century. Little by little, the glowing nebula becomes thinner, more transparent. Its colors soften against the velvet darkness of space. But at its very center, a brilliant point of light still remains. Small, pure white, peacefully shining. This is the heart the old star could not give away. A white dwarf. If the red giant was a gentle giant, the white dwarf is its quiet memory. At first glance, it seems almost impossible. How can something so small have once been a star large enough to fill much of an entire solar system? The answer lies in gravity. When the giant star released its outer layers, only the incredibly dense core remained behind. Everything else had drifted away into space. What was once enormous became astonishingly compact. Imagine taking an entire mountain, compressing it until it could fit inside a single pebble. Now imagine doing something similar to a star. Of course, no ordinary force could accomplish such a thing. Only gravity possesses that kind of quiet strength. The white dwarf is about the size of Earth, yet it contains roughly half to nearly the same mass as our Sun, almost an entire star, packed into a world-sized sphere. Its density is almost beyond imagination. A single teaspoon of white dwarf material would weigh many tons on Earth, far heavier than an elephant, far heavier than a large truck. Yet despite this incredible density, the white dwarf is surprisingly peaceful. Its days of creating energy through fusion are over. The great nuclear furnace has gone silent. No fresh hydrogen becomes helium. No new helium becomes carbon. The brilliant engine that once powered an entire star has finally come to rest. And yet, it still shines. Why? Because it is still extraordinarily hot. The white dwarf is like an iron fireplace after the fire has gone out. The flames have disappeared, but the metal remains warm for a very long time. Now imagine that fireplace containing the heat of an entire star. Instead of cooling overnight, it cools over billions of years. The white dwarf simply radiates the heat it has stored during its long lifetime. Slowly, patiently, without hurry. There is something deeply calming about that. Even after its work is complete, the star continues offering light. Not because it must, simply because it still has warmth left to share. As we drift closer, its surface appears dazzlingly white. Young white dwarfs may glow at temperatures above 100,000 degrees Celsius, far hotter than the surface of our sun. Yet because they are so small, they produce much less total light. From a distance, they appear as tiny, brilliant jewels scattered across the galaxy. Quiet reminders of stars that once illuminated entire planetary systems. Around the white dwarf, The colorful planetary nebula continues expanding. Eventually, after tens of thousands of years, the glowing cloud fades completely into the Milky Way. The white dwarf remains alone, silent, patient. Its companion cloud has become part of interstellar space. Its former planets, if any survive, continue circling a star that is no longer truly alive, yet not entirely gone. Time continues flowing. Millions of years become billions. The white dwarf slowly cools. White becomes pale yellow. Yellow slowly softens toward orange, then a faint crimson glow. The changes happen so gradually that no civilization could ever watch the entire transformation. Eventually, after an unimaginably long time, the remaining warmth fades away. Astronomers predict that a white dwarf will one day become something called a black dwarf. Not because it explodes, not because it collapses, simply because it has finally radiated away nearly all of its heat. It becomes cold, dark, almost invisible. There is one remarkable detail, however. The universe is not yet old enough for a single black dwarf to exist. Every white dwarf ever created is still cooling. Every one is still quietly glowing somewhere among the stars. The oldest are ancient beyond imagination, yet even they continue releasing the last traces of their warmth. In a sense, the galaxy is filled with tiny celestial embers. Old stars, still glowing softly after billions of years. Perhaps there is something beautifully reassuring about that image. Even after the brightest chapter has ended, warmth can remain. Light can continue. Quiet purpose does not disappear simply because life has entered a new season. As we leave the peaceful white dwarf behind, its gentle glow slowly becomes another distant point of light. One more quiet story woven into the Milky Way. One more reminder that endings in the universe are rarely sudden. They are patient, graceful, and often beautiful. Yet our journey through the lives of stars is not quite complete. So far, we have followed the peaceful life of a star much like our own Sunday. But elsewhere in the universe, far more massive stars live very different lives. They burn hotter, live faster, and when their final moments arrive, they transform the cosmos in extraordinary ways, creating many of the heavier elements that would one day become planets, mountains, and even the iron flowing quietly through your own blood. We leave the quiet white dwarf behind. Its soft glow gradually fades into the tapestry of the Milky Way. Ahead, another light begins to emerge. It is brighter, larger. Its color is not the gentle gold of our sun, nor the warm crimson of a red giant. Instead, it shines with an intense blue-white brilliance that seems almost unreal. This is one of the galaxy's true giants, a star born with many times the mass of our sun. If our sun is a peaceful campfire, this star is like an entire mountain glowing from within. Yet despite its enormous size, its life will be surprisingly brief. The universe often reminds us that greater strength comes with greater responsibility. Massive stars live fast. From the very beginning, gravity presses upon their cores with tremendous force. The pressure is extraordinary. The temperatures climb far beyond those inside our own Sunday. Fusion races forward at an astonishing pace. Hydrogen disappears quickly. Helium follows soon after. while our sun can quietly shine for around 10 billion years. A truly massive star may live only a few million. To the universe, its lifetime is little more than a deep breath. And yet, during that short life, it accomplishes something remarkable. As the hydrogen becomes scarce, the star does not stop. Its enormous mass allows gravity to squeeze the core even further. The temperatures rise once again. Soon, helium begins fusing into carbon. Then carbon becomes oxygen. Later, oxygen helps create neon. Neon gives way to magnesium. Then silicon, layer after layer. The star quietly becomes a magnificent cosmic workshop. Imagine slicing the star open like an onion. At the center lies the hottest region. Around it, shells of different elements quietly produce new ones. Hydrogen on the outside, helium beneath, then carbon, oxygen, neon, silicon, each layer performing its own peaceful task, each preparing the ingredients for future worlds. No ordinary star like our sun can create elements much heavier than carbon and oxygen. It simply lacks enough pressure. But these massive stars continue much farther. Deep within their fiery hearts, they forge sulfur, calcium, nickel, and eventually, iron. Iron is special. Unlike earlier fusion reactions, creating heavier elements from iron does not release energy. Instead, it requires energy. The great engine that has powered the star for millions of years begins slowing. The balance between gravity and fusion quietly changes. For countless ages, fusion has pushed outward. Gravity has pulled inward. The two forces have lived together in perfect harmony. But now, the outward pressure begins fading. Gravity patiently waits. It has never stopped pulling. Not for a single second. The core begins shrinking, faster than ever before. Yet even here, the universe remains elegant. This is not a story of violence. It is a story of transformation. The star has completed its greatest work. It has created nearly every common element found within rocky planets. The calcium in your teeth, the silicon inside sand, the oxygen filling Earth's atmosphere, the magnesium inside green plants. Much of it was forged inside ancient massive stars like this one. Without them, rocky worlds might never have existed. As we drift peacefully nearby, the great blue giant continues glowing. Its light fills the surrounding darkness with an almost icy brilliance. Powerful stellar winds quietly carry newly created elements into nearby space. Even before the star reaches its final chapter, it is already enriching the galaxy. Perhaps that is another quiet lesson hidden among the stars. Sometimes, we begin sharing our gifts long before our own story is finished. The universe has always been generous in this way. One generation of stars quietly prepares the next. One cloud of stardust becomes another stellar nursery. One ending gently becomes another beginning. Far below us, deep inside the massive star, the iron core continues growing. Slowly, patiently, almost unnoticed. The star still appears calm from the outside. Its brilliant blue light gives no hint of the extraordinary changes taking place within. But gravity knows. The balance is changing. A new chapter approaches. Soon, the massive star will experience one of the universe's most extraordinary transformations. not as an act of destruction, but as the final and greatest act of creation. For in those last moments, many of the rarest elements in existence, gold, silver, uranium, and countless others, will begin their own remarkable journey into the universe. And perhaps, long after that ancient star has faded, a tiny atom forged in its final moments may someday become part of a distant planet, a quiet mountain, or even the hand of someone gazing peacefully at the stars on a calm summer night. For millions of years, the Great Blue Star has quietly carried out its remarkable work. Deep within its heart, layer upon layer of fusion has transformed simple hydrogen into an astonishing variety of elements: carbon, oxygen, silicon, calcium, iron. The star has become a vast workshop of creation. Now, its final chapter quietly approaches. From where we drift, the star still appears calm. Its brilliant blue-white light shines steadily into the darkness. No distant observer would suspect that anything unusual is happening, but hidden within the core, the ancient balance between gravity and pressure is changing. Iron has quietly gathered at the very center. Unlike every element before it, iron brings fusion almost to a standstill. For billions of years, fusion pushed outward. Gravity pulled inward. Together, they created harmony. Now, the outward pressure grows weaker. Gravity, patient as always, continues pulling. The core begins shrinking, not over centuries, not even over years, but astonishingly quickly. Within moments, the core becomes denser than almost anything else in the universe. The atoms themselves begin changing. Electrons are squeezed into protons. Together, they become neutrons. An enormous wave of neutrinos bursts outward. Countless tiny messengers race away into the galaxy. Most pass through the surrounding star almost effortlessly. Others carry away an extraordinary amount of energy. The core continues collapsing until, at last, it can shrink no farther. And then, something remarkable happens. The collapsing material suddenly meets an incredibly dense neutron core. It rebounds. A powerful shock wave begins traveling outward through the star. For a brief instant, the entire giant seems to awaken. This event is called a supernova. The word often brings to mind violence and destruction. But tonight, let us see it differently. Imagine the final bloom of an ancient flower, or the last golden leaves drifting gently from a magnificent autumn tree. The supernova is not simply an ending. It is the universe sharing its greatest treasures. Within the tremendous energies released during these final moments, something extraordinary becomes possible. Elements heavier than iron begin to form. Gold, silver, platinum, uranium. Many of the rarest natural elements in existence are created during these brief moments of unimaginable energy. The gold inside a wedding ring, the silver in an old family heirloom, the tiny traces of uranium hidden deep within Earth's rocks. All may have begun inside stars like this one. It is a remarkable thought. The universe needed generations of stars and extraordinary moments like these to create the materials that would one day become part of our everyday lives. As the expanding cloud gently moves outward, It carries these precious elements into the galaxy. Some will drift through space for millions of years. Others will join cold clouds of gas and dust. Eventually, gravity will gather those clouds together once again. New stars will quietly form. Around them, new planets will slowly emerge. Some rocky, some icy, some wrapped in deep oceans. The heavy elements created during the supernova become part of those newborn worlds. Mountains rise because silicon and iron exist. Rivers flow through valleys shaped by rocky minerals. Living cells use tiny amounts of metals to perform remarkable chemistry. The universe has quietly recycled one star's final gift into another world's first beginning. Perhaps nowhere is this more beautifully expressed than within ourselves. The iron flowing through your blood, helping carry oxygen with every heartbeat, was almost certainly forged inside an ancient massive star. The calcium strengthening your bones, the phosphorus inside every cell, the trace amounts of copper and zinc that help your body function. Each began its story long before Earth existed, before the sun was born, before our solar system was even imagined. Every atom has its own ancient history. When astronomers say, "We are made of stardust," they are not speaking poetically. They are describing reality. Quite literally, the atoms within you once belonged to stars. Perhaps not the same star. Perhaps many different ones. Each lived, shone, changed, and quietly gave its material back to the galaxy. Over immense stretches of time, those atoms found one another again, eventually becoming oceans, forests, animals, and people capable of wondering where they came from. There is something deeply peaceful about that thought. We are not separate from the universe. We are one small part of its ongoing story. The stars are not distant strangers. They are ancient ancestors. Their light warmed worlds long before ours. Their elements became the building blocks of our planet. And now, through curious minds and quiet evenings beneath the night sky, the universe has found a way to reflect upon itself. As the last glow of the great star slowly fades into the surrounding darkness, the galaxy quietly becomes a little richer than before. More elements, more possibilities, more beginnings waiting patiently among the stars. Ahead, the Milky Way stretches across the heavens like a soft river of light. Within its countless stellar nurseries, new stars are already being born. Some may someday nurture planets. Some may never have worlds at all. But every one of them begins with the same ancient inheritance, the peaceful gifts left behind by stars that came before. The great star has finished its final gift. Its brilliant light has faded into the quiet darkness. Yet nothing has truly been lost. Around us, the Milky Way seems almost endless. A graceful river of soft white light stretching from one horizon to the other. Billions upon billions of stars quietly fill its spiral arms. Some are only beginning their lives. Others have already lived for billions of years. Some are surrounded by newborn planets. Others drift alone through space. Each carries its own story, yet together, they are connected by an invisible thread. The universe remembers. Every new generation of stars is born from the remains of older ones. The hydrogen that formed our sun may itself have traveled through earlier generations of ancient stars. The carbon inside Earth's forests, the oxygen filling our atmosphere, the iron beneath our mountains, all carry memories far older than our solar system. Nothing begins completely new. Everything inherits something from the past. Imagine drifting through one of the galaxy's great molecular clouds. These enormous regions appear dark from a distance, almost empty, yet inside, they contain vast oceans of cold hydrogen gas mixed with tiny grains of ancient stardust. The dust itself is extraordinary. Each microscopic grain may contain atoms forged billions of years ago. Some were born inside peaceful red giants. Others emerged during the final moments of massive stars. Over immense stretches of time, these tiny particles quietly gather together. Gravity, always patient, begins its familiar work once again. Very slowly, the cloud develops regions that become slightly denser than their surroundings. Those regions attract more gas, more dust, more gravity. The cycle quietly repeats itself. Millions of years pass. The cloud contracts. Its center grows warmer, brighter, denser, until finally, a brand new star quietly opens its eyes. The universe has begun another story. Around many young stars, a broad disk of gas and dust slowly circles like a peaceful whirlpool. Within that spinning disk, tiny grains gently collide. Most simply bounce apart. Some quietly stick together. Dust becomes pebbles. Pebbles become rocks. Rocks slowly become mountain-sized worlds. Over millions of years, entire planets begin to appear. Some remain small and rocky. Others gather enormous blankets of hydrogen and become giant worlds. Some settle into quiet orbits where liquid water may exist. Others become frozen realms beneath distant starlight. Every planet, no matter how different, shares one remarkable origin: ancient stardust. As we drift peacefully through this newborn planetary system, one small blue world begins to catch our attention. Clouds slowly circle above broad oceans. Volcanoes reshape young continents. Rain gently falls. Lightning flickers through distant storms. Time passes. Millions of years quietly become billions. Simple chemistry slowly grows more complex. Tiny living cells appear. Life begins, not because the universe planned it, but because the conditions quietly allowed it. The atoms forged inside long-vanished stars now assemble themselves into something astonishing. Leaves, fish, birds, forests, whales, people. Every living creature becomes another way for the universe to express itself. Perhaps the most extraordinary part comes much later. One evening, on one small planet, a curious child looks upward. The stars sparkle across the darkness. Questions quietly begin. What are they? How far away are they? Where did they come from? Without realizing it, the universe has become curious about itself. Through countless generations of stars, planets, and living minds, the cosmos has gained the ability to wonder. There is something deeply comforting about that idea. We are not standing outside the universe looking in. We are part of its story. The atoms within us once belonged to stars. The light entering our eyes began inside distant suns. Even the oxygen carried by every breath owes its existence to ancient stellar furnaces. In a quiet sense, The universe has never truly been separate from us. As we continue floating through the Milky Way, the familiar golden glow of our own sun becomes visible once again. Among billions of stars, it is simply one quiet light. Yet for Earth, it is everything. Its steady warmth has allowed forests to grow, oceans to shimmer, clouds to drift, birds to sing at dawn, children to laugh beneath blue skies. And tonight, it has carried us on this peaceful journey through its hidden heart. Take one slow, comfortable breath. Notice how calm the galaxy feels. Nothing rushes, nothing struggles. Stars are born, stars shine, stars gently change. Then, with remarkable generosity, they give their materials back to the universe. The cycle continues, patiently, gracefully, forever. And as we slowly prepare for the final moments of our journey, one quiet truth remains. Everything you have seen tonight, every ray of sunlight, every glowing nebula, every distant star, and every tiny atom within your own body belongs to the same beautiful cosmic story, a story that has been unfolding silently for billions of peaceful years. Our journey has carried us through the hearts of stars, across glowing nebulae, past quiet white dwarfs, and beside the magnificent lives of giant suns. Now, rather than traveling farther, let us simply drift. The galaxy surrounds us like a calm ocean. Every direction is filled with gentle points of light. Some are so distant that their light began traveling before human civilization existed. Others have been shining since long before Earth itself was formed. Yet together, they create a quiet rhythm, a rhythm the universe has followed for billions of years. Birth, growth, change, renewal, again and again. Perhaps nowhere is this rhythm more beautiful than inside a stellar nursery. Imagine floating into one now. Ahead, a vast cloud stretches across dozens of light years. It is neither empty nor dark. Instead, it resembles soft blue-gray mist illuminated by distant stars. Cold hydrogen gas drifts slowly through the cloud. Tiny grains of ancient dust sparkle almost invisibly. Everything moves, but nothing seems hurried. Gravity begins gathering the cloud together. No sound accompanies the process, only silence. Over thousands of years, nothing appears to change. Then, over hundreds of thousands, the cloud grows slightly denser. Over millions, the center becomes warmer. The universe is wonderfully patient. Where we often measure time in days, nature measures it in ages. Within the cloud, countless invisible particles gently bump together. Hydrogen atoms meet one another. Dust grains quietly cling together. Small changes accumulate, not because anything forces them, but because the laws of nature quietly encourage order. Eventually, deep inside the cloud, a tiny region begins glowing. At first, only faint infrared warmth escapes. The young star remains hidden behind thick blankets of dust. From outside, almost nothing can be seen. Yet inside, gravity continues its gentle work. The newborn star slowly contracts. Its temperature steadily rises. Millions of degrees begin building within the growing core. Then, one peaceful moment arrives. Hydrogen fusion quietly begins. Without fanfare, without celebration, another star is born. The surrounding cloud becomes softly illuminated. Warm golden light filters through the drifting gas. Nearby dust reflects subtle shades of blue and pink. The entire nursery begins glowing like morning fog touched by sunrise. Across our own Milky Way, this gentle miracle happens again and again and again. Astronomers estimate that several new stars are born within our galaxy every year. Not thousands, not millions, just a few. The galaxy never rushes. It has all the time it could ever need. Some newborn stars grow large enough to become brilliant blue giants. Others remain quiet red dwarfs that may shine for trillions of years. Many, like our own sun, become steady yellow stars, perfectly suited for nurturing planets over immense spans of time. Around some of these young stars, planets slowly emerge from the remaining disk of gas and dust. Each orbit settles into its own graceful path. Nothing is perfectly circular, nothing completely still. Everything dances. The planets quietly circle. Moons gently orbit planets. Comets wander in long, elegant loops. Asteroids drift through peaceful belts of stone. The entire system becomes a slow celestial ballet. Perhaps somewhere, one small rocky world settles at just the right distance from its star. Not too hot, not too cold. Water begins collecting on its surface. Clouds form. Rain falls. Rivers quietly carve valleys through ancient stone. The ingredients forged inside stars begin working together in new ways. Carbon bonds with oxygen. Hydrogen joins nitrogen. Simple chemistry slowly grows richer. Life may quietly awaken. It is impossible to know how many such worlds exist. Perhaps only a few. Perhaps millions. The universe remains wonderfully mysterious. And perhaps that mystery is one of its greatest gifts. Not every question must be answered immediately. Some are meant to inspire wonder. As we continue floating through this peaceful nursery, we notice something familiar. The dust surrounding these newborn stars contains the same elements we encountered earlier: carbon, oxygen, silicon, iron, calcium. Nothing new has been invented. The universe simply keeps reusing its finest materials. Again and again, each generation building gently upon the last. There is great comfort in that thought. Nature wastes almost nothing. Every ending becomes another beginning. Every beginning quietly carries the memory of what came before. Far behind us, the old stars continue fading into darkness. Far ahead, young stars slowly brighten for the first time. Between them, the galaxy quietly breathes, expanding, creating, recycling, remembering. And somewhere among those countless lights, our own sun continues shining. Not remarkable because it is unique, but remarkable because it belongs to this beautiful, endless family of stars. A family that has quietly filled the universe with warmth, light, planets, and the possibility of life itself. As we drift onward through the gentle glow of the Milky Way, the stars seem almost close enough to touch. Not distant strangers, but familiar companions, each carrying another peaceful story waiting to be discovered. Our journey through the galaxy has been long, gentle, and filled with quiet wonder. Now, Let us begin the slow journey home. Far ahead, one familiar star shines with a soft golden light. Our sun. From this distance, it looks no brighter than countless others. Just another peaceful point of light among billions. And yet, for us, it has always been home. As we drift closer, the solar system slowly comes into view. The distant worlds continue their graceful dance. Neptune circles quietly through the cold darkness. Uranus follows its gentle path. Saturn glides with its magnificent rings. Jupiter watches over its many moons. Mars shines softly with its rusty deserts. Earth, a tiny blue world, quietly circles the same warm star that has illuminated our journey tonight. From here, no borders can be seen, no cities, no roads, only swirling white clouds, deep blue oceans, and the gentle glow of sunlight reflected from water. It is astonishing how peaceful our planet appears from space. Every forest, every mountain, every quiet village, every busy city exists upon that small blue sphere. Every story humanity has ever told, every song ever sung, every child ever born, every dream ever imagined, all beneath the light of a single ordinary star. Perhaps that is what makes our sun so extraordinary, not because it is unusual, but because it has remained wonderfully steady. For nearly 5 billion years, it has risen every morning over Earth. It has warmed oceans, fed forests, powered the winds, driven the water cycle, and quietly supplied nearly all the energy that life depends upon. Every green leaf owes its color to sunlight. Through photosynthesis, plants gently capture tiny packets of solar energy. That energy becomes wood, fruit, flowers, seeds. Eventually, it becomes food for animals. And for us, even the oxygen filling each breath is a gift made possible by sunlight. Tonight, as you breathe slowly and comfortably, you are sharing in a process that began inside the heart of our sun. Long ago, a photon started its journey deep within the solar core. It wandered for hundreds of thousands of years through the sun's interior. Eventually, it escaped into space. 8 minutes later, it reached Earth. Some of those photons warmed the oceans. Others touched green leaves. Some reflected from clouds. And a few, perhaps, reached your face during a peaceful afternoon. There is something quietly beautiful about that journey. The sunlight we often take for granted has already traveled an extraordinary path before arriving here. As Earth slowly turns beneath us, night gently covers one side of the planet. Cities sparkle like tiny constellations. Above them, the real stars continue shining. For countless generations, people have stepped outside beneath skies like these. Some watch from deserts, some from forests, some from ships crossing quiet oceans, some from snowy mountain peaks. Many simply stood in silence, looking upward, wondering. Those same stars watched over ancient civilizations. They shone above the pyramids, above Roman roads, above medieval villages, above the first telescopes, above the rockets that first carried people into space. Tonight, they shine above us as well, patient, unchanging, comforting. Perhaps that is one reason we find peace beneath the stars. They remind us that there is something larger than our daily worries. The universe moves at its own gentle pace. Stars do not hurry. Galaxies do not rush. Gravity never becomes impatient. Nature quietly trusts time. Maybe there is wisdom in that. As we continue floating above Earth, the thin blue atmosphere glows softly around the planet's edge. Only a delicate blanket of air protects every living thing below. It is surprisingly fragile, yet remarkably successful. For billions of years, it has sheltered life beneath the steady warmth of an ordinary yellow star. That simple combination, a quiet planet, a stable star, and enough time, has produced forests, birdsong, coral reefs, whales, rain, music, friendship, curiosity, and the peaceful moment you are sharing right now. Take another slow breath. Imagine the warmth of gentle sunlight resting upon your face. Imagine a calm evening beneath a clear sky, the first stars quietly appearing one by one. You now know a little more about those distant lights. You know that each carries its own story. Each has lived its own remarkable life. Each has quietly helped shape the universe we call home. And somehow, knowing that makes the night sky feel even more comforting. Not mysterious because it is unfamiliar, but comforting because it is, in a quiet way. Family, soon, our journey will become even slower. The stars will remain above us. The universe will continue its peaceful work. And all that will remain is to rest beneath the same ancient starlight that has quietly watched over our world for billions of years. Our long journey is almost complete. The stars continue shining quietly around us. The Milky Way slowly fades into the distance, until once again, only the familiar night sky remains. Imagine yourself lying comfortably beneath an open sky. Perhaps you are resting in a peaceful meadow or on a quiet hillside. Maybe beside a calm lake where the stars shimmer gently upon the water. The air is cool, soft, still. A gentle breeze brushes across the grass. Somewhere nearby, leaves whisper quietly among the trees. Far away, an owl calls into the night. Everything feels wonderfully calm. Above you, thousands of stars sparkle across the darkness. Some shine brightly. Others appear as tiny pinpoints almost hidden among the blackness. They seem peaceful, unchanging. Yet now you know something few people ever stop to consider. Each tiny point of light is a real place. Each is a sun. Many have planets. Some are young. Some are unimaginably old. Some are quietly creating the very elements that future worlds will need. Others are slowly cooling after lives that lasted billions of years. Every star carries its own history, and every one adds another page to the story of the universe. Your own sun is among them, not the brightest, not the largest. Simply one gentle star among hundreds of billions. And somehow, that makes it even more precious. Without asking for attention, without demanding recognition, it quietly shines every day. Perhaps there is something we can learn from stars. They never compete with one another. They do not hurry. They do not compare themselves to neighboring suns. Each simply shines according to its own nature. The tiny red dwarf quietly glows. The brilliant blue giant burns brightly. The peaceful white dwarf slowly cools. Each has its own purpose. Each follows its own path. Nature never asks one star to become another. It simply allows each to be exactly what it was born to become. As you continue resting beneath the sky, notice how slowly everything moves. Earth quietly turns beneath the stars. The moon follows its familiar path. The planets continue their ancient dance. The Milky Way slowly circles the center of the galaxy, completing one orbit in roughly 230 million years. Compared with such vast rhythms, our own busy lives seem wonderfully small. Perhaps that is not something to fear. Perhaps it is something that brings peace. The universe does not expect us to solve everything tonight. The stars certainly are not worried. They simply continue shining, one moment after another, one century after another, 1 billion years after another. As your breathing becomes slower, imagine each breath arriving like gentle waves upon a quiet shore. In and out, nothing forced, nothing hurried. Just as gravity patiently shapes galaxies, your breathing quietly cares for you. Without effort, without thought, every heartbeat echoes the rhythm of the universe. Steady, reliable, gentle. Somewhere far above, a photon begins its journey from a distant star. It may travel for hundreds, thousands, or even millions of years before reaching Earth. Tonight, one tiny particle of that ancient light may finally arrive. Perhaps it passes through the atmosphere, past drifting clouds, past quiet mountaintops, until it gently reaches your eyes. You are seeing a message from the distant past, a traveler that began its journey long before human history. The night sky is filled with such travelers, tiny messengers carrying stories across unimaginable distances. And yet, they arrive without hurry, without noise. Only light, only patience. Perhaps patience is one of the greatest lessons the stars offer us. Everything meaningful in the universe takes time. Stars require millions of years to form. Planets need millions more. Life slowly unfolds over billions. Even sunlight waits hundreds of thousands of years before escaping the heart of a star. Nature has never been in a rush, and perhaps neither should we. The cool night grows even quieter. The stars continue sparkling overhead. The universe carries on with its peaceful work. Nothing asks anything of you now. There is nowhere you need to go, nothing left to understand. Only this quiet moment, this gentle breath, this comforting sky above. You are resting beneath the very same stars that watched over ancient oceans, ancient forests, the first flowering plants, the dinosaurs, the first people, and every generation since. They have always been there, patient, steady, faithful, and tonight, they quietly keep watch once again. As sleep begins drawing a little closer, allow yourself to simply become another peaceful part of this beautiful universe, floating gently beneath the endless sea of stars. Our journey is coming to its gentle close. We have traveled farther than almost anyone ever does, not only across space, but across time. Together, we drifted into the heart of our sun. We watched tiny particles of light begin journeys that lasted hundreds of thousands of years. We floated through quiet oceans of glowing plasma. We discovered the patient balance between gravity and light. We wandered beside peaceful red giants, admired delicate planetary nebulas, and watched newborn stars quietly awaken inside vast clouds of ancient dust, we learned that every star has its own life, its own rhythm, its own gentle purpose, and perhaps, without realizing it, we also learned something about ourselves. For every atom within your body has traveled an extraordinary path. The oxygen you breathe, the calcium in your bones, the iron carried by every heartbeat, all began their stories inside stars that lived long before our sun was born. You are, quite literally, part of the same universe you have been exploring tonight. There has never truly been a separation. The stars are not merely above you. In a quiet way, they are within you. Take one slow breath, and another. Imagine the night sky stretching endlessly overhead. No telescope, no spacecraft, only your imagination, floating peacefully beneath countless distant lights. Each star glows with calm confidence. None tries to outshine another. Each simply offers its own light. Perhaps there is wisdom in that. You do not need to become anything other than yourself. Just as every star has its own place, you have yours. The universe has never asked the stars to hurry. Spring never rushes into summer. Autumn never hurries toward winter. Galaxies patiently turn through space over hundreds of millions of years. Even sunlight waits patiently before reaching the surface of a star. Nature trusts time. Perhaps, tonight, you can trust it too. Whatever remains unfinished can wait until morning. The stars have waited billions of years. They will still be there tomorrow night, and the night after that. Nothing important will disappear while you rest. Far above, the Milky Way slowly turns around its hidden center. Beyond it, other galaxies quietly continue their own graceful dances. Clusters of galaxies drift through the vastness of space. Even beyond them, the universe continues expanding, as it has for billions of years. Everything moves, everything changes, yet somehow, everything remains beautifully connected. Here on Earth, the night grows quieter, the wind becomes softer, the air grows cooler. Somewhere, a gentle stream continues flowing. Leaves quietly rustle in the darkness. The moon follows its familiar path across the sky, and the stars, patient as always, continue shining. Imagine one small beam of starlight gently reaching you now. Not bright, not dazzling, only soft, comforting, warm in its own quiet way. It settles gently across your shoulders like a light blanket. Another follows, then another. Soon, it feels as though the entire night sky has wrapped you in peaceful light. There is nothing you need to hold, nothing you need to remember, nothing left to solve. The universe asks only one thing of you now: rest. Allow your breathing to become slower, gentler, almost effortless. Feel your body becoming pleasantly heavy, your thoughts growing quieter, like ripples fading across a calm lake. Imagine yourself lying beneath an ancient tree on a warm summer night. Above, the stars quietly sparkle through the leaves. The grass beneath you is soft. The earth feels comfortably warm from the day's sunlight. Everything is safe. Everything is peaceful. Everything is exactly as it should be. Somewhere far away, a tiny new star is quietly being born. Elsewhere, an old white dwarf continues cooling after billions of years. A distant nebula slowly expands. Another planet circles another sun. The universe continues its endless, gentle rhythm. And here, on this small blue world, you are simply resting beneath it all. The same stars that watched over the first oceans, the first forests, the first birds, the first people, now quietly watch over you. Good night, little traveler. Good night, little star. May your dreams drift gently among peaceful galaxies, across warm sunlight, past quiet nebulas, and beneath endless skies filled with calm and ancient light, until morning quietly finds you once again.